Alright, so we've been solving for exact values before, which you should have seen. Now, we're going to do it in a slightly more wider sense. So what that means is we're going to look at all the different values that applies around the circle. So I mentioned last time that you have certain things in which they give you the same values. We mainly looked at the positive rotations. You only really need the positive rotations anyway. You'll see why in a second. But we mainly looked at how there are certain values in which it's going to be the same. So for example, if you're looking at sine in the first quadrant and the third quadrant, they're the same. What that means is we can find all the different values by knowing where they are. And remember I told you to write it down last time, make sure that you have it. So when we're solving for these trigonometric equations, have a look at what the exact value is. Some of them are going to be positive, some of them are going to be negative. For example, if you want sine to be negative, you would actually do the third and fourth quadrant, because they're not positive in these two quadrants. Okay? Then you apply all the values around this region, which means work out these bits. Okay? So you need to look for where the regions are, and then you find the values. If you're not entirely sure, I'm just going to do an example. So, part A, solve the following equations to obtain the exact values for x. So, sine of x equals to root 3 over 2. Here's a test for you again. Where is sine of x? What's the exact value for sine of x? Equals to root 3 on 2. What's the angle? 60. But this is in radians, so what is it in radians? 5 over 3, very good. So that's our base value, okay? Now, I'm currently writing down all the other different values in which we can check them with. So we said the base value is pi over 3. Where else is sine positive? Second region. Now, our base value is pi over 3, so we're going to put whatever this is on the second region, which is pi minus x. So you do pi minus pi over 3. That's the only difference. You just have to add on any values that applies for. So then, pi over 3, what's pi minus pi over 3? What's 1 minus the third, in other words? 2/3, so that's 2 pi over 3. Okay? Part B. If you have to rearrange it, then rearrange it first. What should I do first in this equation? Anyone? Move for plus 1, so we get negative 1. Then what? Divide by root 2. Very good. Oops. Alright, what is cos of x equal to 1 over root 2? Which angle? 45, good. But this is in radians, so what is it in radians?
That's like half pi.
Half pi is 90 degrees. Pi over 4, good. Now, this however says that cos is negative. So we have to take the regions where cos is going to be negative. In which regions are they negative? In which quadrants? 2 and 3. So you would write pi minus that base value, and then pi plus that base value. So you get 3 pi over 4 and 5 pi over 4. Usually people get a little bit confused on the negative one because they have to look at the other regions. Alright. You can also have negative pi's. You can also have negative regions. It's okay, you just have to think about which way we're rotating. We have root 3 minus 3, tan of x equals 0. So I'm just going to rearrange that first. just to save a bit of time. Alright, what's the base value of tan of x is equal to root 3 over 3? Or 1 over root 3? Smallest one? What's the smallest angle? 30. So what's the radians version of that? Pi over 6. Alright, we want all the positive values because this answer is positive. So where is it positive? 1, so we have the first one. And we're going to go this way first. Where's the other one that's positive? For tan. Quadrant 3, so what do I do? Good. Now we're going to go the other way. If we go the other way, this way, this will seem a bit weird to you at the start, but you'll get used to it in a second. If we're going this way and we're going to this region, the tan one, what would I need to do if we're going in the negative direction? Yep, minus pi plus x. There is a cheating way, if you want to know. You just do minus 2 pi, then plus the pi plus x. Okay? Then they'll work it out for you. And the other one? Minus 2 pi, and then plus pi over 6. So if you're a little bit lost on how that one works, you go all the way around, then you go back. But remember, that way's positive, that way's negative. So we're going backwards, then forwards. That's why it's minus and plus. Then once you've done that, you just simply write out all your solutions. They don't have to necessarily be in order, but I would suggest you make them in order. That is not an x, that is pi over 6. What's that? Negative pi, pi over 6, negative 5 pi over 6. Then that's 12, so that's negative 11 pi over 6. Okay? Do we kind of get... Oh, you can't see it. Do we get the idea though? You just simply work out which regions it matches. Alright, you can also solve these with the so we want tan of x, solve tan of x. It's 12.5 because of 0. This one's in degrees, so make sure this is changed. Then negative 180 less than or equals to x, less than or equals to 180. And we'll change it. Now, here are some of the trickier ones. And you'll need two different rules to help you. Number one, remember that tan of theta, or tan of x, is equal to what? Anyone remember? Sine over cos. Okay, so for the first one, we have root 3 sine of x equals to cos of x. If we rearrange this, where we want sine of x over cos of x, we'd have a root 3 here, and we'd have a 1. So now we need to move the root 3, so that we have sine of x over cos of x equals to 1 over root 3. So sine of x over cos of x is tan of x. When is it equal to root 3? Oh, 1 over root 3. $30, yes. What is it in radians? 5 6, very good. What's the other one where it's positive? Which quadrant? 3. So what should I do? Plus or minus? Plus. So you can see you guys have to really memorize which one it is, because you're expected to know it. Alright. Part B, we've done this earlier on in the year. You have to do some substitutions. So, see how this looks like a quadratic equation? If I substitute cos of x equals to u, you can pick any letter. People normally just use u. Then you have u squared plus u minus 2 equals to 0. So when you factorize this, what do you get? It's plus 2 minus 1 because you have a plus 1 here. Okay? Oops. Then write it down as your two equations. Now, this first part is actually impossible.
Why?
Because cos of x can never be greater than 1 or less than 1. So sine of x and cos of x must be between 1 and negative 1. I'll explain that a bit more when we do graphs, but that's the rule. So what that means is this is not possible, so we eliminate that answer. Then cos of x is equal to 1. When is cos of x equal to 1? Good. What's the other one? If you go around in a circle, it will still be at 1, wouldn't it? So what's the other answer? Very good. Alright, last one. Now, for some reason this is now in year 11, so it's not that hard. The book tells you to solve the values and then cross them out. There is a much easier way, so I'm just going to explain you that easier way, and this is called implied domains. What an implied domain is if you have any shifts, you shift it so that when you solve it within that domain. You'll see what it is when I show it to you, instead of me explaining it. Now, if you have a look at the first one, it says solve cos of 3x equals to negative a half between 0 to 2 pi. What you need to do first is you need to take out this 0 to x to 2 pi. See how inside the bracket it says 3x? We're going to times each part of these by 3. What's 3 times 2? Now, if you think about it, when you solve for the solutions, at the end you have to divide each one by 3. That means you have more answers than you normally have, which is what this is meant to show. So this is the implied domain. So then what you do, you solve it so that you have all of these values. So cos of 3x equals to negative a half. When is it equal to negative a half? Anyone? A half is when you have 60. Yes, 60. So that's pi over 3. So let's write them out. Pi over 3. The other one, we want negative. So we want pi minus pi over 3, pi plus pi over 3, and you can see this goes on for a little while. Now, the reason why this is annoying is, see how that goes to 6 pi? You have to solve it to 6 pi. So then you have to add the next rotation on. So currently, we've gone through the circle once. We have to do it again and again. But it's easy to do the rest once you have the first two solutions, because all we have to do is add how much to it, to each one, to do one more revolution. What's one revolution worth in radians? 2 pi. So we just add 2 pi to each one. So that's 3 pi minus pi over 3. 3 pi plus pi over 3. Then the next one, 2 pi. We're adding 2 pi. So 5 pi. Work them all out. 2 pi over 3. 4 pi over 3. 9 so 8 pi over 3. 10 pi over 3. 5 15 so 14 pi over 3. 16 pi over 3. See how that's 3x? Now we divide it by 3, which puts us back in the original domain. So x is equal to 2 pi over 9, 4 pi over 9, 8 pi over 9, etc. It's easier when you try it later. Alright, so we can do the same thing with the other ones. See this one, I might just do the implied domain. When you solve it, it's pretty much the same anyway, so I'll just show you what the implied domain for this one is. I might solve it separately on a separate slide and I'll record it later. So 0 to x to pi. Do you times 2 first, or do you subtract it by pi on 4 first? You times it first. Then you subtract it by pi on 4. So 7 pi over 4. Alright. I'll add this on a separate slide later. You just have to work out all those different bits. I probably don't have enough space anyway to work it out, so I'll just leave it there. I'll record on a separate slide. You wish you could go back to what? Polynomials. Well, calculus is polynomials. When is tan equal to -1? When so we want pi minus pi over 4, 2 pi minus pi over 4. We need to also add all the other negative ones on, so going back this way gives us negative pi over 4, so that's one of the values. Then we also have, no, that's it, because I want 7 pi over 4. So then 2x minus pi over 4 is equal to negative pi over 4. I'll just put this in order. So then we have 3 pi over 4 and 7 pi over 4. Then we need to add pi over 4 in each one. So we get 0, pi, 2 pi, then divide by 2, 0, pi over 2, and pi.